So the topic today is feature engineering. So the very first question that arises is what is feature engineering? So as the name suggests, it's all about features. What a feature is, it's basically some individual measurable property, or in simpler words, it's like basically individual measurable inputs. So, feature engineering. So, if you have already worked with some machine learning models, then you must have noticed that we have a few conditional variables, and we have some decision variable. So, based on those conditional variables, we need to predict decision variable for test data set. So, that is what the like basic models are all about. So, feature engineering is the procedure of converting raw data or raw tables into features, usable features, using statistics or machine learning approaches. So, raw data is converted into features by using few procedures. There are few steps like selection, followed by manipulation and transformation. So selection, what selection is, basically if you have a lot of features, so all of the features are not ready to use, or maybe all of the features are not that you don't need to use all of the features. There are features which will be like highly correlated. For those features you can discard a few features and you can take some features, or maybe you can just combine few highly correlated features and get some new feature out of it. So that is what basically selection is. Then manipulation is basically about feature extraction. That is, if you have a very few correlated features, then maybe you can combine a few of them and get a new feature. That is manipulation. So feature, the basic difference between feature selection and feature manipulation and feature extraction is, for feature selection we need to keep those features, we need to select among those features which are original features. And in feature manipulation we can combine features, we can get new features out of old features. And then transformation is, we need to make sure that the features in all of the rows have the same unit. Maybe for one row it is of one unit and for some other row it is of another unit. Then our models will be working with numbers, so if there are different units it would be like a huge problem. So we need to basically convert them all in the same unit. So that is what basically transformation is. So following these steps, selection, manipulation, and transformation, we'll be getting features out of raw data, which is like we can use to train our model on. So feature engineering, that can be used for both supervised and unsupervised learning. As supervised learning models are more common, let us take some unsupervised learning model as example. Say we need to we need to create clusters out of some database. We have some data points, and the database is a customer database which is for a shopping mall. See, we need to create clusters so that the owner of the mall can know that how many categories of customers are there. Based on that, maybe he can have different offers for the customers. He can, like, he or she can have customers who purchase products more frequently, or those customers who will be not purchasing products like that frequently, they can have different offers for them. So what we can do, maybe if our database do not have one column for gender, we can add one column for gender. Like, it would be one useful feature when we think about clustering. Because for male female, they will be having different sections in their shopping mall, so they should have different offers for them. So we can include new features. Or what we can do, like, as one customer can come to the shopping mall multiple times in a year, so what we can do is we can group by the data entries. each of these entries we can group by them by individual customer, and we can have one new column which would be indicating average amount spent in shopping in that mall on yearly basis, like on annual basis. So in both of these cases, we are somewhat generating a new feature. But feature engineering is not always about generation or creation of new features. Like in feature engineering, feature extraction and feature selection both are part of feature engineering. Uh, I am quite sure, like if like people here have worked with some basic models at least, they have faced this problem like somewhere, because we don't really work with some very structured databases. We definitely have some faults in there, like maybe few rows will be having some missing values, or maybe some would be having some wrong values. The values that are supposed to be there are not there. Instead we have some other values for that. So we have all handled these missing values, maybe if there are two types of variables, like numerical and categorical. So if those are like numerical variables, then for we can just replace those missing values using min or maybe minimum or maximum out of all those values in that column. Or if it is categorical, some categorical variable, maybe we can just discard those rows which are having um, missing values, or maybe we can take the most frequently occurred value for those which are having missing values, and we can replace it with them. So this handling missing values, this have a very fancy name. We call it imputation technique, which we will be discussing about later. So there are two types of feature engineering. One is manual feature engineering and another one is advanced feature engineering. Now, advanced feature engineering is more about automation. Now, manual feature engineering, we cannot have a very hard and fast rule for manual feature engineering. It is based upon domain knowledge, and it is based upon the situation, what all techniques we should use or we are supposed to use. But there are a few techniques like which are very handy in different, like if you have already been in any competition on Kaggle, then you might have used these techniques. So I'll be discussing about a few techniques. The very first one is combining less popular categories into others. Maybe suppose you have some data set which is about some online shopping thing, and you have one feature or one column which indicates from which e-commerce website or from which e-commerce company the product is been purchased. Now, in that particular column, you can have different categories. You can have very popular companies like Amazon, Flipkart, Myntra, and you can have few less popular companies which occur very less frequently in the column. So for those less popular companies which occur very less frequently, you can just keep them in some category called others. Because if you have less categories, it is helpful in creating clusters. A lot of categories, even if you just consider categorical variables and one hot encoding, which I'll be talking about later, even then, like if you have less number of categories, it would be helpful for clustering algorithms, for using clustering algorithms. Then the next technique you can use is frequency count. That is, as I have, like for the previous example which I have given for the clustering one, there you are counting the, like how many times the customer has visited the shopping mall. So you are just counting the frequency, and out of that you are getting the average amount that is spent in the mall. So that is another technique that you can use. And the third technique I'm talking about is extracting substrings of from IDs. If I just consider this database, so we see that we have a column called cabin, the second last one. So there we have, say we have some string, we have some categorical data, which is not that useful, but maybe the first letter C that can indicate which type of cabin the passenger is in. So that can be helpful because that can work like some categorical data which is useful for the model. So basically extracting substrings from other strings can be proved to be some helpful technique. Now some more techniques in feature engineering, as I have already talked about imputation, which is basically handling missing values. Now there can be two types of variables, numerical and categorical. We have different techniques to handle numerical imputation and categorical imputation. For numerical ones, we can, as I have already mentioned, that we can take the minimum or maximum out of all the values and replace the missing value with that value. Or maybe we can even simply discard those rows having missing values. But one disadvantage of doing that, though it is very simple to do, we may lose a big chunk of data there. Because if too many rows are having like missing values, we need to discard them all. For categorical imputation, we can follow the same. We can use one hot encoding and we can change categorical variables into numbers, into codes. And we can follow the same methods. Or we can just replace the missing values with most frequently occurred value in fact. Then the second thing is handling outliers. So outliers can basically be removed, or for like imputation only, the values can be replaced also. One hot encoding is basically for categorical data. Say for some categorical feature, we have n different categories. So we, for n different categories, we can have different codes. For each different category, we can have one code associated to that. Say for categorical way, like category 1 we can have code 0, category 2 we can have code 1, and from 0 to n minus 1 we can have n different codes, and we can treat those codes as numerical variables only. Then log transform is basically used to reduce the skewness of the data. Like if the data is more asymmetric, then we can try to use log transform to make the data more symmetric. And if log transform is not enough, we can even use some more advanced techniques like power transform or box-Cox transformation. Like I have some example. If you have some asymmetric data like this, I have they have plotted the data here, and if you it is plotted with Seaborn, and if you are having some asymmetric data like this, you can basically use box-Cox algorithm, box-Cox transformation algorithm on it, and you will be having much more symmetric data, which is much more easier to work with. And one more thing is scaling and normalization and standardization. I hope that is a very simple yet important concept. For normalization, if x is the variable or the categorical variable or feature, then you, for normalization we use the formula like x minus x min by x max by minus x min. And for standardization, the formula is x minus x min by standard deviation. This is for manual feature engineering, we can use this all these things. Like I'll be sharing few like codes also, so so that you can just get some idea how to use them in practical. Now, manual feature engineering is like a terrible process, because you can there can be there can be so many things which can go wrong. So we tend to use automatic feature engineering, though we need to use some things manually there, but we can just automate the whole procedure to some extent. One such tool is Featuretools, so which is a framework, an AutoML framework that we can be using for feature automated feature engineering. I have one example using Featuretools, which I'll be sharing. The implementation I am sharing right after I presenting these slides. So the very few there are a few disadvantages also, because all the tools do not support structured data, like unstructured data. Also, all of them do not support relational database. Like there are a few tools which will only support, like which will only work on single table. It won't work on relational tables, like relational database, that won't work when on multiple tables. But there is some good community support, good documentation, but it is a bit complicated, so it's not that much easy to use for novices. So the very first tool we will be using is AutoFit, which is very simple to understand. And the reason I like it a lot, because it is having a very similar interface like scikit-learn. So it is very easy to remember and very easy to use, and also can handle categorical features. But the problem with it is it cannot handle missing values, so we need to take care it of first, and then we need to use AutoFit. TS is some classification, regression, and feature engineering tool, which is available in Python. This is best for time series classification and regression, and can be integrated with feature tools. This is not that much widely used, so we will get a very few examples of using it. The next one is 1BM. This is the most advanced tool that I have used till now. This is on Kaggle, we have seen that it has records of outperforming set of arts models. That is, it is very like advanced model, and it works on both relational and non-relational data, generates both simple and complex features, whereas like feature tools, those are that generally generates very complex features and very complex to use. Though this is complex to use, but it can generate simple features as well, and it performs really well because it directly interacts with raw data or raw tables. uh, so I think we can just go to the practical part now. So for practical part, I am using my Kaggle notebook to just give example of each of these tools. For AutoFit, okay, so for AutoFit, we definitely need to first install it, like as I have done here. You need to install it, import libraries, and there we are loading some like toy data sets here. Okay, so I have already loaded IIEST. That is one very popular toy data set. We can just search for other data sets as well. First, let us run it on this data set only. and we are using autofit regressor here. So autofit is basically we are having automated feature engineering integrated with linear regressor. So we also have a classification algorithm, like similar way, but we are like the data set is like the algorithm we need to use for this data set is regression algorithm. So I am using the autofit regressor only. So let us just run. Let us print the data set to see here. We can just convert it into data frame. Okay, all right. All arrays are not of similar length, so we cannot convert it into data set. All right. Here we are creating training sets and test data set. Here is our auto regression model. So as we can see, this is like this methods or functions are very similar to scikit-learn functions. So here is we are having the fit transform method, which is also present in scikit-learn interface, and the predict method, which is very similar to the scikit-learn interface. So as we can see, the R2 score is 0.9333. Is that a good R2 score? Like, do you know what R2 score is? Anyone? All right. So any R2 score that is like above zero point 0.9 is a very good R2 score. So this is a very simple data set or very simple database, like toy database one. But still, this is a like good result for something automated. This is really good. So that is all about auto fit. We can similarly take an example of TS Fresh, which is about like time series. Let us import the files, sorry, libraries. So there are a few example data sets or databases in time series fresh. So we have some database called robot execution periods. So here time is time only. Fx, Fy, Sz. Those are like forces. X component of force, Y component of force, Z component of force. Tx, Ty, Tz. Those are like X, Y, and Z components of torque. So first we are doing feature extraction. That is, out of these features, we are creating or generating new features. And let us see how many new features we have created. How many features we have here is one, two, three, four, 6, 8. We have 8 features here. And how many features we have created? Let's see. Let us print the head. So there are 5 rows and 4,734 columns. So we have created these many columns out of only 8 columns. After feature extraction, we can perform feature selection, which is like out of these many columns, like 4,734 columns, we can select a very few columns because all of the columns are not useful. There are few like highly correlated columns, so we need to just drop them off. So the final database that we are data set we are having is X filtered. Let us print it. So we are having 682 columns. That is, out of 4,734 columns, we are having only 682 columns. Now, what we can do, we can just simply take like 2 training data sets and 2 test data sets. That is, we are taking the data like the set simply, and after feature extraction and selection, we are taking that like modified data set as well to compare them. So this one, which I'm about to like run, this one is like the extracted and filtered set of features. So let us see how well it performs. Okay, now let us perform the same algorithm, that is decision tree classifier. On this set, we haven't performed any like extraction or selection on. As we can see, the value is somewhat different from the previous one. It is on the selected like selected and extracted feature one, we are having like better result there. So that is all about PS Fresh. You can always go to like you can always go to the official documentation and search for what doubt you are having there, because you need to like Google a lot, because like this is a lot of things and it's very difficult to remember. So just need to understand the documentation, how to use each of those methods and use them properly. The next tool we are talking about is feature tools. In feature tools, we'll be using these feature synthesis that will be used for generation of new features out of the database we are having. So first we need to just import the library. Then again, we are having some demo. We are having some mock customer database for demonstration purpose, which is having like data frames in it. One is customers, one is sessions, and one is transactions. So we are having 3 data frames, and we are like printing those data frames. The customer data frame is having like 4 features. The session data frame is having 4 features, and the transactions data frame is also having 4 features. So the very minimum input set for deep feature synthesis is data frames, relationships, and target data frame. As I have already mentioned that feature tools is one of the very few tools which work on relational databases. Relational databases means you have a few data tables which are related to each other, and if you provide those relations or relationships, then you can work on some particular data frame. That is, here the data frames that we have are customers, sessions, and transactions. So we have them in one array. That is our data frames array, which we need to provide as an input. Then we need to provide relationships. So for each of the relation, we have some special format. That is, the parent data frame is to be mentioned first, followed by parent column, followed by child data frame and child column. So let us take one example. Like here, sessions is the parent data frame, followed by parent column, which is session ID, and the child data frame is transactions, and we have a similar column in that, which is the child column, session ID, similar column. So this is one relation. The first line is one relation, and the second line is another relation. So in this way, in relationships array, that is one 2D array, we will have different relations. That is the second input that is to be provided to DFS function. And the third input that is to be provided is target data frame name. Say we want to work on, say, customers data frame, then we need to provide customers as like third input. So this is how DFS works. So after we pass those inputs to DFS, we get some feature matrix out of it, and that feature matrix is printed here. We are having different features out of those features we already had in customers table. As we can see, we have count, we have mode, we have unique numbers, we have maximum, min, minimum, also mode, skewness, standard deviation, sum, like all different arithmetic and vector operations are performed, and those extra features are added. Now you can perform feature selection on those extra features. There can be features which are not to be considered. So that is where data engineers use manual engineering, feature engineering. Now you can also have like a graph feature. You can see how each of your features get transformed. So you can use graph feature for that. You can also use describe feature to get more idea about new features. So that's how you use DFS or like feature tools. So the simplest one is AutoFit. So you can just go to Kaggle, and you can just enter that keyword AutoFit. You will get few notebooks, and you can try to run like copy and edit each one of them. If you run each one of them, then you will be getting some idea how to, like, in which situation to use which algorithm or which tool, which technique. You'll be getting some idea. So the one database or data set you can work with is the very simple one. Every beginner just try this one first. That is the Titanic data set. You can just there are a few notebooks on AutoFit, like automated feature engineering. So I found this one. I can provide the link in the group. You can just go through the book. There are links provided for EDA, which is like the visualization part, which is also a very major part and related to feature engineering, and feature engineer optimization is also there. There are many links. You can go through the links and like go through the articles and notebooks and just get some idea about feature engineering and EDA, how they are related.